Ready? Boom. There we go. Let's get back to our notes. Okay. All right, you guys said everybody equal to 2,000. My kiddos that are gone, or at least not here yet, we're just finishing the example from yesterday. So we're setting the whole puppy, the whole equation up from above equal to 2,000. All over 1 plus 4, 9, 9, 9, e to the negative 0.8 t. I would have multiplied up first, right? And then maybe divided over.
Yeah.
So then you would have gotten on this side 1 plus 4, 999 e to the negative 0.8 t equals 5 halves. Can I do that? 5,000 over 2,000? We have to subtract the 1, yeah? So we can't touch any of this stuff until we get rid of that 1 plus on the outside. Subtract that 1, then divide by 4,999, so I have e to the negative 0.8 t equals 5 halves minus 1. Isn't that 5 halves minus 2 halves?
Yeah. So it would be 3.
I kind of like thinking of 1 as 2 halves. It makes everything a little bit easier. So 5 halves minus 2 halves is 3 halves. And I'm doing 3 halves divided by 4,999. So I was pulling him over 2. How do I get to that t if he's in an e? Log base e or? Yeah. Yeah. So I can go ahead and take ln of both sides. So ln of him, ln of him. Save place, save place. 1 over negative 0.8 times ln of 3 halves over 499. 9. There's one more. There we go. Put my calculator. Oh, not. Let me double check you because you guys hopefully already got here, yeah? So 1 divided by negative 0.8 times ln of 3 divided by 2 divided by 4,999. You get 10.139?
Yes, ma'am.
Ooh, so what does that mean in context with the problem? You have to understand this.
10 to 11 days. They will shut it down.
Don't need to round it, right? So, in 10 to 11 days, they will technically cancel classes, right? Okay. Why do I say 10 to 11? Yeah, if someone's smart and thinking ahead, they're going to do something like, ooh, we're going to hit 40% today, let's just cancel classes. If they're a little bit meaner, they might be like, it wasn't this morning. Anyway, either way. Somewhere between 10 and 11 days, they're going to cancel classes. In context. Okay. So yesterday, we got the idea of having a word problem, having some sort of model given to us, and then using it to solve, and we have to read the problem carefully, figure out who the variables are, and figure out then what did they give us that we know that we can plug in, and what do they need for us to solve because we don't know that they want us to find. Now, let's go ahead and go look at how the problems can get different. My kiddos that have their spirals out, help me out really quickly. You have at least 1 or 2 of these. Which ones are you guys doing for homework? 7 and 10, that's it?
Yeah.
Okay. Then let's go ahead and do let's do number 8 and number 12. Make it exciting. Okay. When you see when you read this and see compound interest, question. Based on what we did yesterday in class, where should your mind naturally go? Really quickly. Hopefully. Maybe not quickly.
Formula.
Formula! Yesterday, we talked about a formula for compound interest, and the compound interest was, well, hold on. What kind of compound interest? Weren't there 2 different ones? One with an n times per year, and one with an e continuously? Which one's this? Continuously. So we know that a is equal to per. P times e to the RT. Now, hold on. Look at these columns over here. What does initial investment represent, or what is it represented by in the formula? P, good, the principal. Where we started with. Rate. Oh, that one's easy. It's R. Time to double. Well, was that T? It is a T. We gotta figure that one out. And an amount after 10 years. Well, amount after 10 years, that's A of 10. Right? A after 10 years have gone by. So time to double. This is T when. It's not every T, but it's T when double. What's doubling?
The A.
The A. Doubling of what?
Doubling the principal.
So I can say A is double the principal. Those are our clues for each of the different columns. The first one is just the principal. The second one is just the rate. The third one is, here's the T it takes for A to become 2P. 2 times the original. And then the amount after 10 years is, hey, when T is 10, here's how much you have. So for number 8, we have this formula to start with. What can we plug in?
We can plug in P.
Okay. So we can plug in right here, 750. What else?
The rate.
So E, do I put 10.5?
No, we put 0.1.
0.
That's a percent, right? So I have to make it into a decimal to make it all nice and
And
pretty.
since it's double, we can just take 750 by the 1500.
Yeah. Time to double. Sean's just doing it because that we're doing the whole like, hey, well if it doubles, that means it goes from 750 to be what? 1500. We can solve for T now, right? And since we know it's double, divide by 750, it's a 2. We just talked about how do you undo an E. That reduces that away. We can do 1 over 0.105 ln of 2 equals T, so T equals, we had to plug in, but we had to do that little like, wait, if it doubles, that means the money is twice what it was to begin with. We had to do that little thing, making 750 1500. Or making A 1500 double 750. But otherwise, we're just plugging and chugging, right? So let me check you, because you guys probably are ahead of this on me. What'd you get? Go. No one? Okay, 6.601. Someone back me up. Come on, you typed in wrong numbers before.
I got you, Sam.
Nice, nice, nice. And we're doing years, right? I think T is measured in years.
So,
Hey, we filled in the blank, right? But we have one more. Okay, what's the other blank?
the amount after the year.
Okay, the amount after 10 years. Well,
So now we have a T.
we take our formula, right? An amount. Well, I don't need to write the letters, do I? Can't I just write the math and say, hey, we're solving for A of 10? Amount after 10 years, A of 10, so I say A of 10 is equal to 750 e to the 0.105 of times 10. Huh. Plug that up in, so move it back in on this one. This right now.
2,143.
Nice, thanks guys. So how are we going to write that? 2,143 and always 3 decimals. Not in this one. Why? Who is he?
Because it's money.
He's money. We round him to the nearest cent. And put a label next to the number. Not the variable. Dun 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 dun. Oh, that wasn't bad. Nicole. The next one gets harder, so it's up to you.
Oh, you got this.
Okay, I'll wait.
Eric's looking out for you. He's like, I don't know. Okay, here we go. Number 12. I'm going to move number 8 down here because he's kind of done.
Let's rock it.
Hey, Sean.
Are you guys ready? Start with the same formula. Plug in what you know. Start with the same formula. Plug in what you know. We're going to number 12. You guys have lots of confidence since I just said it was harder. Sorry.
Okay, you guys. Why I never get recognized? I have no recognition for this job.
Uh-oh. Can we plug in P? Can we plug in R? What can we plug in? T is 12 at one point. Alright, fine. T is 12 at one point, right? So we can say P e to the R, T is 12 at one point. Struggle. How am I going to solve for anything? Wait, at what point is T 12?
Double, so it's
So I can take out the A and put in the,
2P.
why is that so cool?
Why is two?
Because now we have a common.
Because if it
common-
doubles, that means that what's over here is twice what it was over there. Remember before we had 750 and we doubled it and put it there? So, A says, how much do you have? Well, at 12 years, I have double or 2 times what I had originally. So I got to take out the A and put in the 2P because that was my clue. We just had to kind of put it in mathy terms to understand it. Now, how does that make it any better? We still have a P and an E and an R and a, I don't even know. Oh, E's a number. Oh, P does what? Remember, Sean, you were like, wait, if we know it's double, then it's always going to be 2 when you divide. Exactly. It's going to be 2 when you divide.
And then, yeah.
How do you get rid of E?
Swoop it out. Remove it and flow.
So ln of 2 equals, isn't it just 12R? Or R12, but 12R is much less awkward.
Oh.
Not the awkwardness is bad. And then R is equal to?
5.
Now, we could go ahead and get like an actual decimal, and that's not necessarily bad. I'm going to go ahead and write it. R is equal to, hold on, Sean, I'm checking it. Let's make sure. Go ahead and read what you got.
I have 0.0578.
I am totally agreeing.
So percent terms of
Yeah. Why did he keep 4 decimal places? Yeah, you can convert to a percent, and that'd be 5.7.
Yeah, I have to keep my sig figs in check.
Maybe we'll keep that. For being super snazzy. Oh, look, now there are 3 decimal places in my percent. We could be super snazzy, but that's okay. Either way, I also wouldn't mind 5.8% because that's theoretically, that's technically 3 decimal places from the get-go. Either way, so that's R. That's the rate. That's good. But what else do we need to solve for?
The initial.
Oh. I used the 12-year clue, right? Maybe I should use the other clue?
Okay, so since we have the rate, and they give us a time, and they give us the final amount, all we have to do is just use the rate right there, the 10.
Why 10? I
Because
see
it's
2,000.
around 10. Because if we're going to the right and we're going to use this clue, it says it's the rate after 10 years. And we know that in the end it's going to equal 2,000.
Who am I solving for? It's like a puzzle. We just gotta figure out where to put the pieces and who we're solving for. But you see how it was a little bit trickier? Because the very first one, it was like, we don't have anybody. Well, we kind of did. We had to start plugging stuff in. Why do you think I used ln of 2 over 12 instead of 5.776%?
It'll be more accurate.
More accurate, less error, because no rounding. Great. Oh, remember on this one back here? We were using the clue 12. It takes 12 years for the amount that you have for A to double what you had initially. So, what am I doing? Oh, guys, isn't this the easiest one? I know it looks funny because you're like, ew, that's gross. But look, it's all a number. Just divide. Oh, all right. E to the ln of 2 over 12 all times 10. Don't even have to take any ln. It's 2,000. Double check me. Divided by e to the power of ln of 2 divided by 12 times 10. What do you guys got? Uh-oh, my coach is good. Say the numbers. What'd you get? Okay, fine. I'll say it. And are you agreeing with me? $1,122.46.
I got it.
Oh, that's super fancy. I got you.
Yeah, you have to, if you're writing the ln, remember it's ln of 2 only. So ln of 2, close the parenthesis, then divided by 12. That's probably one of the biggest mistakes. 1,122.46. cents. People without calculators, you trust in them? People with quieter dispositions with calculators, you agreeing with us? So, is this table as scary as maybe it was last night if you started? Hopefully not. Well, let's go ahead and check one more table, because there's one more coming a little bit later in homework. There. Radioactive, ooh, radioactive decay, that sounds fun. It's okay. Okay, we're gonna do the math. Here's the crazy thing. Question, does anybody see a formula they give us?
No.
Well, they didn't on the last one either, but they said compounded continuously. We connected it to a model that we knew showed or modeled that situation. Decay, isn't that one of the words?
Yeah.
Exponential decay? What's that formula?
Y is equal to A e to the negative 3x.
Can I change something real quick?
Sure.
Can I make x into a t because we're talking about time? Is that okay?
Yeah.
Alright.
Well, why not?
Can I label a few things too? You ready? Well, actually, no, let's discover. Kiddos that have their spirals out, I'm sure you have something between 21 and 24. What do you guys have?
21 is
Ooh, so let's do 20, they're the same thing. Huh. Let's start with 22. Start with 21. Start with 22, and then we might move to 23 just to make sure we know the idea. 22. Who is that? Yeah. So we have carbon, who has a half-life of 5715 and an initial quantity of 6.5. So I don't mind the T, because that's like an X. I don't mind the Y, that's like a Y, it is a Y. But I don't like the A or the B. I really want numbers in there. Initial quantity. Do I know anything about initial quantity? Yeah, what's your T?
0.
0. Because T is time, and time at the beginning is 0 of any situation. So we can just say it's 0. So our initial quantity, T is equal to 0, and then half-life, years. These are T's, right? T, when the amount is 1/2 the principal. Wait, what? We're not talking about money. Yeah, but it's kind of the same idea. When we have an equation, and this looks kind of like PERT, right? When we have an equation, we're saying that this is how much we have, or the amount that we have after a certain period of time with an initial. So technically, we can have this little a be our initial, and then this is our amount after t years. If you don't believe me, we could do it like this. We could say y, the amount, is equal to, for number 22, the amount is equal to 6.5 grams when the time is 0. So we could take that little initial clue. We could say, okay, we know the t and we know what amount we have. So let's say we have 6 when t is 0. But guys, what's anything to the 0 power? Close. 1. So then I can say, oh, a is equal to 6.5. Isn't that the initial? Oh yeah, it's where the principal went with the money one. Okay, so it's the initial, it's the beginning amount. So I can actually go really quickly and I can already just plug in the initial amount into that P spot for the continuously compounding interest. Just this is applied to a different situation. Now I have e to the negative b times t, so you can kind of think of him as rate. But, yeah, I don't have him though, right? So I've used the initial quantity clue. What other clue do I have? The half-life. Okay, this is a little tricky. Half-life, that's the t, right? So I can plug in t to b, well, 6.5. E to the, I don't know, b. T is 5 715, holy cow, it's a long time, for the amount to become what?
Half of the.
Half of what it was originally. So what's half of 6.5? It's cut in half. 3.25. So then we can say, all right, let's go ahead and divide by 6.5. But Sean, remember, wait, if it's half, what's going to happen when I divide? It's going to be 1/2. He's half of who this guy is, so as soon as I move that guy over, whatever, it's a half. I didn't even actually need the number. And I have e to the negative, to make it look pretty, 5715b. What do I need? The natural log, right? Throw that ln in, throw that ln in. The e gets canceled, or I should say probably reduced. I divide by my negative 5715. B is equal to negative 1 over, I'm dividing by 5715, 5,715 years, whew, times ln of 1/2. Now, technically, could I get a decimal? Yes. Why am I not going to? Is that filling in a blank? Is that giving an answer? Is there a spot for rate? But I'm going to use him, but I don't want to round him if I'm going to use him for a future answer, so let's just leave him the way he is. I want to find the amount after 1,000 years. Huh? Oh, wait, what's my equation? Oh, wait, what did I just solve for? No, wait, what are they asking me for? Plug it in, plug it in, plug and chug everything. Plug and chug, first of all, the initial amount, 6.5. Plug and chug, well, E's E, whatever, he stays. Plug and chug negative times B, well, B is a negative 2, okay, whatever. Negative 1 over 5715, ln of 2, times T is 1,000. Struggle. 1,000. Ah, there he is. You guys check it. I'll check you. Either way. Negative as negative is a positive. And the logarithm, and then times 1,000. You guys. Oh, what did I not write? What did I not write? Oh no, it was a 1/2. You know how I figured that out? It starts at 6.5 and it's decaying, and I got 7.3. That doesn't make sense. One more time. You guys saw it though, right? I wrote ln of 2. That's not right. I should have rewritten ln of 1/2. One more time. Times ln of 1/2. And the ln, put it in 1,000, and starts with 5, I think. 5, 4, 7, 5. So we could say 5.7. Mine's a little bit different. You might have rounded him a little bit. I ended up keeping him whole. Does that look good? Wait, but who? Grams. Okay. Dun, 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 dun. Actually, I think he might have been kind of the hardest. Well, it's going to be a little different for number 23 or 24, I should say. Well, I just might have to plug in the clues in a little bit different spaces, kind of like the compounding interest one. Nicole, if you want to run to the restroom, go ahead. The rest of you guys, here's what we're going to do. Remember what our goal was for today? To be as done with section 3.5 as possible, so that we can start our review, so that you can work tonight on the review and come tomorrow already with some basis of, here's chapter 3, here's what we're facing, here's what we need to go ahead and solidify for our test on Friday, right? Okay. So as a result, or in order to help you achieve that goal, we are just going to finish class with, oh no, where is he? There he is. Workday. You need a book, come to the front. You need a book, come to the front. If you want to move around, if you work better with someone else beside you, go ahead. If you want to stay where you want to, go ahead. If you don't have a calculator, hopefully you have a calculator, run your locker, you know? If your book is really close by, go ahead and go run and grab it from your locker. You can be working on 3.5, trying to finish. You can start working on the review, because you want to have as much attention by tomorrow so that we can ask questions, master things, work them out, work out the kinks before the test. But you start wherever you need to. Maybe it's 3-5 because you had a busy night. Maybe it's the review. Maybe it's finishing 3-5. And hopefully today's examples help. Are we good? Are we golden? Got it. So tomorrow we'll do like focused all together review. Today is just kind of a work day to save you guys time. Did they steal them all? Ooh, these, I think I have one that's on the cart, left hand side, underneath the blue one. Is there one down there? Okay, you can borrow it. Alright, we all booked? Sweet. We have both assignments up, so whatever you can do. Remember the test review. Do you have to write directions problems for this one? No. This one. For the ones with big nasty word problems. You're summarizing just the big idea, maybe an important formula to use. Sound good?